In this video, we're going to cover learning objectives B and C. So we're going to graph sine and cosine functions given the equation or the scale and translation rules, and we're going to state all the key components about them: the amplitude, period, phase shift, and vertical shift. So let's get started by just looking at a parabola like we would have back in chapter 3 and see what happens between doing a scale change and then doing a translation. So if we take a parabola here, the parent function is y equals x squared. These are the ordered pairs that sit on the parent function as we see in these 4 points. Now what they want to do is they want to go to the graph and they want to stretch it horizontally 2 times and stretch it vertically 3 times. So when you do that, this blue graph will stretch out this way and it'll stretch up. So what they've done to write the equation is, notice right here, they went to the x value, and instead of multiplying by 2, they went in and divided x by 2. But be careful, it's just to the x's being divided by 2. They come in and square the whole thing. Now to the y, instead of multiplying the y by 3, they brought it over to the y and they divided it by 3. Now you may be used to seeing this equation instead of, it would be y equals 3 times x divided by 2 all squared. So in that case, remember, everything backwards for x, but the same for y once it's on one side. Now look at the ordered pairs and to see what's happened. They took the original ordered pair of -1, 1, and all they did was put -1 in for x and the 1 in for y. When you put in that ordered pair, it now switches to -2 and 3. And they did that with all the other 3 ordered pairs. Notice -2, 4 goes to -4, 12. And now we see the actual stretch. Now the next thing they want to do is take the green graph and embed on top of it. Here they want to move it right 1 and down 2. So to move it right 1, they're going to go to the x and they subtract the 1. They're going to go to the y and now they're going to add the 2. Again, if we had it in our other format where everything was on one side, what you would see would be the x minus the 1, and then they're going to come over here and do minus the 2. So again, the x is backwards, but the y is the same. So these are the same equations. Now, how did they get the graph to go there? Well, they took the ordered pair from this other equation, from the middle one here. For example, they took -2, 3, which sits on the green graph, and they put it in this translation rule. So if you put -2 here and then 3 in here, where that's going to move to is -1, 1. They did that with all of these other ordered pairs from the green graph, put them in this rule, and we got this new graph. So they could graph it and get the equation. So let's look at another parent function of just a parabola. And we're not going to graph this one, but I want you to see if you can figure out which of these 4 equations is the correct equation if we do this to the graph. We want to stretch it 3 times horizontally and 2 times vertically. We then want to shift it left 4 and up 1. Now, the way that they're writing it here is they're going to do backwards for x like we always do, but because they put it with y, you do everything backwards. So let's do the x first. We're going to go to the x and we're going to add 4. So it's either this one or this. They're going to go to the y and they're going to go backwards and they're going to subtract 1, which is like this. So when you look at it, we can already deduce this is the correct equation. Again, all they're going to do is backwards for everything. So instead of multiplying x by 3, they divide it. Instead of multiplying y by 2, they divide it. Now if they were to clean up this equation, what it would look like would be the 2 would be here, x plus 4 divided by 3 all squared would stay the same, and it would be plus 1. So again, they're taking the y's in this case and doing exactly what we want on the other side. So graphing the translations and scale changes together works exactly as it did in chapter 3. All that they're going to tell us here is, I want to highlight, here's the scale change rule of a and b, and here's the translations of plus h or plus k. What this book likes to do, again, is everything backwards. We know for the x then, Instead of adding h, you subtract it. Instead of multiplying x by a, you divide it. They also choose to go backwards for everything on the y right here. So instead of adding k, they subtract k. Instead of multiplying by b, they divide by b. Now, the only difference between Chapter 4 and Chapter 3 is there's some vocabulary that goes along with all four of these different changes. We've talked about them, but let's just recap it. Remember the amplitude. The amplitude is going to come from the vertical stretch, which sits here in the ordered pair, and it's just the absolute value of it. The period also comes from the stretches, but it comes from the horizontal stretch. What you're going to do is take 2 pi, which is the period of sine or cosine, and either multiply or divide to make it bigger or smaller. Now, the phase shift, that's related to a translation. The phase shift is right here in the ordered pair. It's what you do to the x value. And the vertical shift, the axis that's vertical is the y, is what you're going to add or subtract to the y. So that's where you get all the information. So let's just start doing these. Here we have this graph of the cosine. They want us to identify the 2 different sets of ordered pair rules and all the vocab that goes with it, and then just graph it. So first of all, the parent function is cosine. So let me just sketch a cycle of cosine from 0 to 2 pi, maxes out at 1. There's our parent function, getting us ready to sketch it. Now, in the x's, we have 2 things going on. We have a plus pi and a divided by 3. So for the scale change rule, it looks like the x's need to be multiplied by 3 because it's backwards. There's nothing for the y. For the translations, remember translation starts with a t. It looks like a plus sign if you make a lowercase t, so that's how you can remember it's the adding or subtracting. So for the translation, in here we have x plus pi, so it's really going to be x minus pi. And again, nothing added or subtracted to the y. Well, based on that formula, here's what we know. We know that the amplitude, if there's a stretch, is going to show up right here. This is really just a 1y. So the amplitude of those humps is still going to be 1. It's not going to be changed. The period comes from this component right here, the horizontal stretch. Well, the period of cosine is normally 2 pi. But what are we going to do to it? We're going to times it by 3. So it's actually going to go to 6 pi. Now the phase shift, that means what happens to the x's. And on the phase shift here, I'm just going to say we're going to go left pi units. The vertical shift is right here, and there is no vertical shift, so I'll just put that there is none. Now, to graph this by hand, I would recommend doing it alphabetical. Scale change comes before translation, S before T. You will make fewer mistakes if you do the scale change stretch first and then go in and translate. So let me show you. I'm going to come on in here and actually change the amplitude and the period because those are the stretches. The amplitude stays the same, but the period now goes from 0 all the way out to 6 pi. So I'm going to have to extend out our graph just a little bit to 6 pi. So I'm going to take this point here and push it all the way back. Now notice the same C shape that we see right here now has to happen between 0 and 6 pi. Well, it's going to bottom out in the middle. The middle of 0 and 6 is at 3. So at 3, I'm going to put that graph bottoms out. Well, where is it going to cross the x-axis between here and here? Between 0 and 3 pi is 1.5. So that's 3 pi over 2. And between 3 and 6, the middle is going to be 4.5, and that is right here. So the stretch, when I redraw it, is that blue graph right there. Now, let's take that stretched graph and actually translate it. What we have to do to the phase and vertical shift is this. I have to move this left pi units. That means this little point right here has to go back a complete pi unit. So let me take it and put it right there. This one that is sitting at 1.5 pi has to go back a full piece of pi, so it's going to sit right here. So let's move that to right here. 3 pi is going to go back to 2 pi. 4.5 is going to go back to 3.5. And 6 will go back to 5. So if you connect the dots, the green graph is what this equation looks like if you were to do it in your graphing calculator. Let's do this one here. Now they already have it grouped with the corresponding letters. So let me show you though, if they had given you a different format, it would have looked like this. So you can interpret either from this format or this, it's the same thing. I'm going to actually write down the ordered pair rules first. Let's do the scale change rule here. So the stretches, or the multiplying, it looks like x here is being divided by 3. So I'm going to go and multiply x by 3. And it looks like that the y is being divided by 2, or when it's over by itself, it's just 2 times the y. So in words, we are going to stretch it horizontally 3 times and stretch it vertically twice. Now the translations, what's going to happen to those? This is x plus pi, so it's going to be x minus pi. And then on this side, we have y minus 1, or when it's by itself, it's plus, so it is just going to be the y plus 1. So we can now identify the key terms. The phase shift, we know, is just right there, so I'm going to say it's left pi units. The vertical is right here. We're going to go up 1. The amplitude is this number, so the humps are now 2 units high. Now be careful, the period is the one we have to modify a bit. The period isn't 3. The period is normally 2 pi for cosine, but it's going to be multiplied by 3. Therefore, the period goes to 6 pi. So let's go to the next slide and actually graph this by hand. So the key to graphing, again, is to first identify the parent function, which is the cosine. So I'm going to do one sketch of the cosine function from 0 to 2 pi. So we have that. Let's next start with the stretches. So you want to do your amplitude and your period changes here because we do have them. And I'm actually going to do them at the same time. So what I'm going to do is if you can see now, the amplitude, this hump is 1 unit high, and so is that. I need to make it 2 units high. So I need to move this point to 2, and I need to move this point down to 2, and that one up to 2. So I'm going to stretch it. But at the same time, the period has to go from 2 pi, stretched all the way out to 6 pi. So let me do this first. Let's change this amplitude up to 2. And then I'm going to take this point and I'm going to stretch the period all the way down to 6, but then I have to raise it up to 2. Now in between 0 and 6 is 3 pi, so this thing is going to be stretched back down to 2 again. So at this point, if I connect these dots, 1.5 goes here, 4.5 here. I just graphed 2 stretches at one time. I changed the amplitude, so we can say the difference between 2 and -2 is 4. Cut it in half, the amplitude's 2. And then the period here is 6 pi. Now, the last step, all I have to do is I'm going to take the 5 key points on this blue graph, and I'm going to move them backwards to the left, a pi unit, and up 1. So I'm going to take this point, go back a pi unit, and I'm going to move it up 1 to there. This guy goes back a pi and up here. 3 goes back a pi and up. This goes back a pi and up. This goes back a pi and up. If you connect the dots, the green graph is what this equation would look like. Now let's take a look at this one. First thing you're going to notice, there's only really 2 numbers going on. So there's only 2 things of the 4 happening, and it's all happening to the x. So that means our period is going to be impacted and the phase shift will. The vertical shift won't, nor will the amplitude. Now, there's a key issue here though. Before you interpret this equation, you must have the x isolated by itself, and it's not. It says 2 times x, and you cannot interpret it that way. Here's what you have to do. This is incredibly important. You must come in here and pull the 2 out. Now, I'm just going to keep it like this for now. Notice how the x is by itself. Here it's not, so this is fine. My question for you is, because I pulled the 2 out of here, I'm also pulling it out of here, so I have to decide what goes in this place. The easiest way to do this is to, since you're pulling a 2 out, is to multiply the bottom by a 2. And let me show you. 4 times 2 is 8, so this really becomes pi over 8. Here's how I know. If I were to redistribute this through, look what I would get. 2 times x is 2x. 2 times negative pi over 8 would be negative 2 pi over 8. Well, this negative 2 pi over 8 is just the negative pi over 4, so I know I'm correct. Now we're ready to interpret what's happening. So it must be cleaned up like this, otherwise you are going to have the incorrect phase shift. Let's do the ordered pair rules. The scale change on here, the only thing going on to x is it's being multiplied by 2, so it's divided by 2. Nothing for the y. The translation on here, it's x minus pi over 8, so it's really x plus pi over 8. And there's nothing for the y. Since there is no vertical stretch right here, the amplitude stays at 1. This is going to impact the period. The period is normally 2 pi. But this says take your x and divide it by 2, so take your period and divide it by 2. The new period of this graph is pi units. This is the phase shift, so we're going to go right, pi over 8. And there is no vertical shift, so I will just say none or 0. Let's practice graphing this one by hand. Now, the parent function here is the sine graph, so I'm going to go ahead and sketch the parent. The S shape starts at the origin, ends at 2 pi, cuts in between at 0. The top hump is between 0 and pi at 1. The bottom one is right here. So that's the parent function of sine. Remember, your next step is going to be to come in and do your amplitude and period, or your stretches. The amplitude stays the same. These humps are still just 1 unit high, so that's great. The period is pi. So I need to take this and shrink it in. So the new sine function will start here, and it's going to end here this time at pi. Means it cuts at pi over 2. So right in here is where you're going to see the S shape happen. So that is the shrink of it, cutting it in half and getting a period of pi. Now the last step, we're just going to come in here. There is no vertical shift. The phase shift is move everything forward 1/8 of a pi, so just a little bit. So to right there, there, this moves, this, and that. And when you sketch it, you'll get the new green graph. And that's the picture of the equation. All right, I want us to look at one more. Now, when you look at this equation, it really brings more together. The parent function here is the sine, but before you interpret it, we do have the issue. Look at the x. It is not by itself. You must clean this up before you interpret it. So I'm going to do this. I'm going to come in here, pull the 3 out. If you do that, what does this become here? It becomes pi over 3 if you factor it out. Again, if you were to redistribute this, 3 times x is the 3x. 3 times pi over 3 would be the pi, so I'm correct. Now you can interpret the ordered pair rules. Here are the 4 choices. One of these 4 is the correct answer. Well, one thing I know, x has to be subtracting pi over 3. So it's going to be either this or this. There is nothing adding or subtracting to the y, so there is no vertical shift. Now here x is being multiplied by 3, so we actually are going to divide x by 3 and multiply the y by 2. So letter B is the correct ordered pair rule for this. Okay, let's use this information and identify the vocabulary. The amplitude, remember, is right here. So the amplitude is going to be 2. The period is impacted by this shrink. Period used to be 2 pi. This says to divide it by 3. Looks like it shrinks to 2/3 of a pi. The phase shift is right here. and it's actually left pi over 3. There is no vertical shift. I'm just going to put 0. So let's go ahead on the next slide and sketch it. Okay, our parent function is sine. Should be getting used to this by now. Let's just sketch that in real quickly to start with. Now let's go on in and do our stretches. So I'm going to do this at the same time. I'm going to raise the amplitude up to 2. So this hump has to go from 1 to 2, and this one goes from -1 down to -2. But at the same time, the end of my graph can't end at 2 pi. It has to end at 2/3 of a pi. So I'm going to shrink this all the way in to here. So I'm going to keep the starting point here first. Then I'm going to move this ending point. I'm going to take 2 pi and shrink it in to about right here. So that's the start and the ending of my S shape. So somewhere in here I have to make it. Now the amplitude has to be 2, so I'm going to have to do something extreme. So I'm going to cut this right in the middle. Looks like it's about there. And in the middle between the first 2 dots, I have to raise it all the way up to 2, so about there. In the middle between the last 2 here, it's going to drop down to -2. So if you connect these dots, what you're going to get is the amplitude and period change. Now we need to wrap it up with our translations. There is no vertical shift, but my phase shift is going backwards or left 1/3 of a pi. So take this, now this is 1/2, so not quite the full thing, go about right there. And we're going to take these and just kind of move them accordingly and re-sketch our graph, and that green image is going to be fairly accurate to what it would look like.